In lesson 7.2, we're going to look at the Pythagorean Theorem. So for that, Pythagorean Theorem, first off, only works for right triangles. And a right triangle is a triangle that has one right angle. And a right angle means 90 degrees, so it's like a corner. So a 90-degree angle will look like this. So if it's a right triangle, one of the angles is 90 degrees. And if you look down here at our examples 1, 2, and 3, this little square in the corner is telling us that's 90 degrees, that's 90 degrees, that one's 90 degrees. So they each have one that has 90 degrees in it. Those would all be right triangles. And then Pythagorean Theorem, that is a squared plus b squared equals c squared. And a and b are called the legs, and then c is the hypotenuse. And then, so remember about that, the hypotenuse has to be the longest side. And to make sure that it's the longest side, it will always be across from the right angle. So if we draw ourselves an example over here, let's take a right triangle. Any right triangle will do. Okay? And in the right triangle, these sides A and B can be used interchangeably. One's A, one's B. Doesn't make a difference which one. But the one that does matter is right across from the right angle. This is the hypotenuse. That has to be C. So A and B are called legs. And the C, the longest side, is called the hypotenuse. Okay, and then we have the converse to the Pythagorean theorem, and that is when we're going to use the Pythagorean theorem backwards. And we can use this to check if a triangle is right. So that would be if you have a triangle and you're not sure if it's a right triangle or not, we can plug it into Pythagorean theorem, and if we get something that's true, then it's a right triangle. If we get something that's not true, then it would not be a right triangle. So let's start with number 1. So the longest side across right angle C, so that's the hypotenuse. So then I'm going to pick one of these to be A and one of these to be B, and we're going to plug it into Pythagorean theorem. So A squared, so that's 35 squared, plus B squared, and that would be 39 squared. And again, these can be flip-flopped. It doesn't matter which one's A, which one's B. What does matter is that it has to be equal to C squared. I don't know what C is, so just leave it as C squared. And then we're just going to plug into a calculator. We're going to do 35 squared. That means 35 times 35. And that is going to give us 1,225 plus 39 squared. That means 39 times 39. And that is going to give us 1,521. And it is still equal to C squared. Then I'm going to combine these like terms. So this 1225 and the 1521, those are like terms, so they're just plain old numbers. So we're going to add those together, and we get 2,746 is equal to C squared. And then this is like the equation that we were solving in our first lesson. I need to solve for c, but I have c squared, so I need to get rid of that square. So the opposite, take the square root. But I'm going to do the same to both sides. So I have to take the square root of the other side also. And those cancel out. So that gives me my c hypotenuse equals. And then we're just going to round this 52.4022. So let's round to 52.4. And then we're going to repeat for the next one. Okay, so for number 2, a squared. Well, I don't have it a this time because here's my b, so this has to be b. That means the other leg has to be the a. And then the one right across from the right angle always has to be c. So a is going to be 58 squared plus b, we don't know, so it's just going to stay b squared is equal to c squared, and c is 67, so 67 squared. And then we're going to stick those in the calculator. So let's do the 58 squared first. That means 58 times 58, and that is going to be 3,364 plus, I don't know yet, so we're going to leave that as b squared. But I can put that last part in the calculator. So that's going to be 67 squared, means 67 times 67. And that will give us 4,489. And then this one's a little bit different. We can't just take the square root right away. We have to get that b by itself first before we can do that, which means I need to get rid of this 3,364. It's positive right now. So do inverse operations, opposite. We're going to minus it from both sides. Well, one from the left here, and then one from the right over here. So that's going to leave me with that b squared. And then when we subtract those numbers, we get 1,125. And then I want to get the b all by itself. The only thing I have left to do is take the square root to get rid of that square. Same on both sides. So then the b equals, we're going to round again. We get 33.54. So we can round that to 33.5. And then one more like this. Okay, so in this one, I have an a listed here. This must be the b because the one right across from the right angle has to be the c value. So this time we have a squared plus, I know the b this time is 16, so 16 squared is equal to 45 squared. And a, we don't know, so it's going to stay a squared. And then we'll do our 16 squared, so 16 times 16, and that's 256. And then we'll do our 45 squared, 45 times 45 is 2,025. And then before we can take that square root again, we've got to solve this to get that a, in this case by itself. So we're going to do opposite of plus 256 is minus 256 on both sides. And that means I've got a squared is equal to 1,769. Last step now, get that a all by itself. I don't want a squared, I want just a. So to get rid of the square, we take the square root of both sides. So our a value has to be approximately 42. See, we get 42.05, so let's round that to 42.1. That means this side, a here, will be 42.1. All right, next type of questions. Determine whether a triangle with a given side, so it's giving us A is 13, B is 8, and C is 21. We can draw a picture if that would help us. We'll just draw any right triangle because we're just trying to get an idea. So it doesn't have to be the exact triangle. We're just trying to give us a visual. A is 13, B is 8, and the C, remember, C has to be across from right angle, and C is 21. So just to help us visualize, it wants to know, is this a right angle, a right triangle? If it is, this would be where they would be placed. So let's see. I'm going to plug in a Pythagorean theorem. So A squared, so 13 squared plus B squared is 8 squared. Does that really equal C squared or 21 squared? So we don't know if they're equal. We're going to find out. So we're going to do 13 squared first is 169 plus 8 squared is 64. Does that really equal 21 squared, which is 441? And then we're just going to add the like terms on the left. So we add the 169 plus 64, and we get 233. But does that equal to 441? It definitely does not. So then this would not be equal. So then it is not a right triangle. Because if it was, then the Pythagorean theorem would be true. And since it's not true, it can't be a right triangle. So we're going to repeat the same for number 5. 24 squared plus 31 squared equals 38 squared. Do 24 squared first. It's 576. 31 squared is 961. And then we do the 38 squared is 1,444. And then we add up the like terms on the left. And we find out that they are not equal. So again, I would say that no, this is not a right triangle. And then we'll do one more. So got 57 squared plus 76 squared. Does that really equal 95 squared? So I'm going to put these in the calculator. 57 squared is 3,249. 76 squared, 5,776. And then our 95 squared will be, I'm squeezing here, 9,025. And then we're going to add up our 3,249 with the 5,776. And we get 9,025. Does that equal the 9,025 we had on it? And then this time, yes, it is. That is equal. So then, yes, it's a right triangle. So that's how we can use the Pythagorean theorem to check and see whether or not something is a right triangle or not.